learning
right.
it from big F to...
So let me give you a summary of a trick. So tangent plane equation to a level surface. Cool. Take your gradient of your function, dot it with your displacement vector, so x minus a, y minus b, and z minus c. Set that equal to 0. And then we need a little bit more here, right? So we need f of x, y, and z, right, is some constant. Doesn't matter which constant. So we need to start with this situation at, my point here is a, b, c, right? And I really should remember one more thing, which is that I need to take this gradient vector and
Evaluate it.
yeah, it's got to be evaluated at the point, right? A, B, C. Otherwise, I'll screw up and I'll have x's, y's, and z's in there, and there'll be too many, right?
We can go there even if we started from fxy.
Yeah, so if you start with fxy, you need to set it equal to z and then subtract it over to the other side so that you can get to this situation. Does that make sense?
Yeah.
But this thing does a little more than the other one. This will do spheres, right? You see that? Yeah.
Can you clarify one thing?
Mm-hmm.
So, when it's set up as fxy, that's technically your z.
Okay, so I have f of x and y is some formula, right?
Yeah. No,
Okay,
it's
so-
not, it's not about this. It's just basic.
You're right.
Yeah.
Yeah. Yeah, yeah.
Z
No, yeah. No, I'm just saying that
equals
like
whatever.
that's 2D.
Yeah, so this is a function from two variables, right? And
Yeah.
it gives an output.
Yeah, and then our output's a variable because it's a dependent variable. We don't
Mhm.
count it as one of those variables.
Well, the graphs of this are going to be three-dimensional.
Yeah, the graphs of this are going to be three-dimensional
Okay.
because there's two inputs and one output to draw.
Okay.
So when I have one of these guys, right,
That's 4D.
this would be 4D, but when I set it equal to a number, right,
Then it's just 3.
then it's 3D.
Then it's a,
But it
it's a
doesn't have to be a
slice, it's
function, right? It could just be a ball or something. It doesn't have to pass the vertical line test anymore.
So didn't we get tangent planes yesterday by taking fx and fy to point, then you have your f of xy. It's the same thing here, but now we can do like the underside of circles and weird.
Yeah, we can
graph
get.
and-
Yeah, we can get.
We can do it with things that aren't functions.
Yeah, exactly.
Okay.
So yesterday we did these for surfaces, right?
Yeah.
And if we solve things like this, right, we could maybe try to solve this for z. If you could solve it for z, right, if you could write z as a function of two variables, then you'd be set. You could do the same thing we did yesterday. But sometimes I don't have a chance in heck of doing that. The sphere is an example where I probably could start, right? I'd get two answers from a plus or minus square root, but I could figure out which one it was supposed to be. There are other kinds of functions, right, that I could, like, if I wrote down z plus sine z minus x plus y is 0, right? I haven't got a chance in hell of solving this thing for z, right? I could solve it for x or y and think of it as a function in the other way, but it's not impossible to think of maybe tangled in all three variables, right? This thing I can do with this technique,
Okay.
but I couldn't do it with the one I learned yesterday.
So this technique that we just learned today, we can use it for everything now. Because it doesn't matter if it's a function or not.
Yeah, you can use this for,
Everything.
as long as you can take the gradient, right?
Yeah.
So I need it to be at least a little bit nice, right? It's got to be differentiable in all three variables. But then once it's differentiable, yeah, go for it. You might have to think a little bit to get these guys into that form, but it'll work. Cool.
What are those situations again where you won't be able to do a gradient, where you won't be able to take your gradient? Is if you're at a peak?
Yeah, sharp.
Yeah, if there were sharp points in one of the directions or something, then my f, x, or y, right, might not exist at all. Like if I had a function that was my earlier with an absolute value of x, right? This is differentiable lots of places, but not at anywhere where x is 0. You guys see that? So it's similar to the criteria that you would apply in Calc 1, except it now boils down to it needs to work in all 3 places, not just one of them or 2 of them.